So let's get started with our first session, History of Salmon. So misconceptions from students include that our bears eat them, that they were always here. That's a funny one. There is a unnamed museum in Michigan that has like a mural on the wall of Native Americans, in their traditional loincloths, standing at the side of the river and spearing salmon. Which, in theory sounds great, except, we live in Michigan and salmon weren't here until the 1960s. So that was probably not a traditional activity back when that was traditional attire. So some interesting misconceptions in the state. So that's one of the things we try to help with. Why are salmon even here in Michigan? Because they're not native. And what part do they play in the ecosystem? We all know that they're quite yummy and they are fun to fish for, whether you fish, in a boat out in one of the Great Lakes or on a river. They're, a super fun species to catch. We have multiple salmon species, which some people don't know. So there's a lot of things that we can help convey to our students. But the salmon story does not start here, right? So my boss usually does this presentation at live workshops, and he, calls this the greatest fish tale ever told. So the story of salmon starts with a different species. Actually, it's called the seagoing rocksucker by some people. That's not its real name. And its native habitat is that brown section up the Atlantic Ocean. So they're native to the Atlantic Ocean, and then they would go up these rivers, as you see, into the mainland to spawn and then die. So native to the Atlantic seaboard. And they were never found in the Great Lakes, as far as we know, until the early 1800s. Now, as you can see, they're through all the Great Lakes and then all of the rivers and tributaries coming off of them. So they've become an invasive species in the Great Lakes system, but they are not a fish you might normally think of. Any guesses? Sea lamprey. So our sea lamprey, like I said, native to the Atlantic Ocean. So for a long time, scientists at like the Great Lakes Fishery Commission or USGS, it was kind of assumed that sea lamprey made their way from the Atlantic Ocean down the St. Lawrence Seaway into Lake Ontario, but they could never get past it because there's kind of something in the way, right? Then we started doing things as humans, right? So we started building all these canals. What we figured out now by the timeline is they did not necessarily come down the St. Lawrence Seaway into Lake Ontario. They were always present in the Hudson River coming out of New. Then we built the Erie Canal, and then we also built a little nub to connect to Lake Ontario. So now it is pretty well documented that this is probably how they got into the Great Lakes system, because we built the canals connecting a river that was not terribly long and connected directly to the Atlantic Ocean to the Great Lakes system. So they still couldn't get everywhere, right? Because there was kind of something in the way, and it's a big something. Niagara Falls prevented the movement of those sea lamprey into the other Great Lakes. So they may have gotten into Lake Ontario, or they may have been in Lake Ontario all that time, but they couldn't get past this natural barrier. But then as humans, of course, we had to evolve and modify the world for our needs, and we messed it up again. So we started building the Welland Canal circa 1825 with picks and shovels and a lot of manpower. They were paid like 10 cents a day to build the canal by hand, and they did that. So the Welland Canal bypasses Niagara Falls here by cutting across this little peninsula and connecting Lake Ontario to Lake Erie. So we've got the Welland Canal now. When it was first dug, it was only, 8 feet deep and not terribly wide. You can pretty much see the width here. So it was not a huge canal, but it did allow vessels to cut between those lakes and opened up shipping opportunities. But again, as good humans, we had to evolve and make bigger canals. So as bigger ships were being produced or bigger ships wanted to connect those systems, we built bigger canals. And over the years, it was improved and deepened and widened over and over again until you get what we have today that is quite large and quite deep and can allow monster freighters through. So that shipping traffic brings in a lot of money. And of course, that's important to the economy. So this was an important piece of infrastructure to keep updated and make larger and accommodate these vessels. So you have ocean-going vessels that maybe come from the Baltic Sea or from the United Kingdom, come across the Atlantic Ocean through the St. Lawrence Seaway into Lake Ontario, and then using the Welland Canal, they can get into the rest of the Great Lakes and maybe drop freight off in Chicago, which is a big hub. So kind of important pieces, but it wasn't the only thing it let through, right? So those sea lamprey get into the system and start wreaking havoc because they have that ability to go from saltwater where they live as an adult to freshwater to spawn. Then the young live in freshwater stream bottoms for maybe even up to 10 years. They can adapt easily to the Great Lakes ecosystem. They don't need that salt water is what we ended up figuring out. So we start seeing them early on in the 1800s, but by the 1940s and 50s, this is pretty typical to see. So you're catching, lake trout. Commercial fishermen were pretty much the only people fishing for lake trout, but they're using their big nets out in the Great Lakes and they're bringing up tons and tons of lake trout with sea lamprey attached to them. The sea lamprey actually use this disc mouth to suction on and pierce the skin, and they kind of slurp body fluids. So they're not vampires. They don't drink blood, but they definitely debilitate the fish because they're weakening them. They're drinking those body fluids and plasma. So you are, weakening this fish in massive amounts. So lots and lots and lots of fish are having this happen to them. Now, the lamprey don't necessarily kill the fish, right? Because they're drinking body fluids, not like chomping on them. But when they detach, when they're full, they kind of leave big open sores. Well, what happens to big open sores when you can't treat them with antibiotics or neosporin? Well, that is usually what kills the fish. So we had a thriving lake trout population that has now been completely demolished by this invasive species. Those commercial fishermen are basically out of business. They, don't have anything left to catch. They don't really have another large species like that they could catch in nets that would be replacing this income from lake trout. So it was a huge loss to the economy and the culture of Michigan with our Great Lakes fishing. So here's kind of the invasion map. So by the 1850s, the Welland Canal was 1825 or was started in 1825, but the Erie Canal was a little bit earlier. So by the 1850s, they're pretty well documented in Lake Ontario and commonly seen or caught. By the 1920s, they're in Lake Erie. By 1931, they're in Lake Michigan. 36 in Lake Huron. 36 in Lake Michigan, and then 38 in Lake Superior. So they spread very quickly and became abundant in number. So if you remember their life cycle, they're going to hang out as adults in the Great Lakes, feasting off of those large fish. Then when they feel the need to spawn, they swim up rivers inland, spawn in those rivers. Their eggs settle to the bottom. The little baby fish hatch, and they hang out in the sediment, actually buried in the sediment with just their little filter feeding mouth above. And then they eat plankton for maybe up to 10 years. They live in that sediment, and they slowly change their mouth. Their mouth actually modifies, and they get that parasitic mouth. Then they make their way out to that Great Lake and begin feeding on large fish. Well, of course, the population took a bit of a hit when we lost all the trout, but there were other species in the Great Lakes, right? We have, pike and whitefish and all these other fish out there. So they weren't the only thing, but they were definitely the thing most impacted because they were that large-bodied fish. So here's a little bit more about that life cycle. So again, they attach to the adults. The eggs and the babies live in the sediment. They kind of look like green beans at that phase. And then they slowly morph into the adults in that transforming phase and then swim out to the Great Lakes and impact those lake trout. So they are big. These are potentially very big fish. They are not an eel. So here's a demo body of one. So they have those fins along their back, but no like, pectoral fins or pelvic fins, none of the fins underneath. They have that prehistoric looking mouth, that circular mouth where let me try to get it up here a little bit more. So that circular mouth, when they're swimming, it's kind of collapsed and folded, and then they open it up to suck onto the fish. Their gills are just openings in the side of their body. They don't have like operculums or covers for their gill openings. It's just literally a pit in the side of their body. Very, very simple prehistoric fish. So now you have this big fish munching on, oops, I put my other fish too far away from me. I can't. You have, that big lamprey munching on, our lake trout out in the lake. And, this is a pretty standard size for a lake trout. So this is a big fish, right? So you have these huge fish being impacted. We lost that fishery. Now they're spawning in rivers all over the state, and we have a big problem, right? So they fully get through that system, and you can kind of see how the population crashed. It has its ups and downs, all throughout kind of, the recorded history of the population. These sea lamprey get common in all the Great Lakes, and poof, down it goes, almost to zero. Completely decimated the population. So now there's no commercial fishing opportunities for these, and there never was much of a recreational fishery for them because they hang out pretty deep. So we had to start implementing some controls. So some of the first controls were weir and trap systems. So a weir is like a little baby dam, goes across the river that just prevents that upward migration of these lamprey. So the lamprey run into the weir, they can only swim this far, and they get pushed into traps on the edges. Sometimes they're enticed by pheromones into those traps, and then we can pull them out of the system. So that was one tactic. The next tactic was to develop a chemical, and they did that in the 1960s. So it's called TFM, and you can see exactly when we introduced it, right? So you introduce it in the 60s, and poof, down goes the lamprey population. It's a little colored chemical. This is like a hose drip line across this stream. So after all this research, we know what streams lamprey are going up in, what they prefer to spawn in. So we can target streams specifically. We target them at a particular time of year where we can have the most impact and kill the most larval fish or eggs. And they perfectly dose the amount of TFM for the stream volume and flow to treat that system. It very specifically targets lamprey. It doesn't hurt much else. So that's a good thing, right? You never want to use a chemical that's, decimating the system. So it very specifically targets lamprey. We do have some species of native lamprey that are teeny tiny and live in the rivers, but it's kind of a trade-off, right? You kill the invasive lamprey, but you might take a few of the natives with it. They also can harm salamanders and frogs if they were to be laying their eggs in the water, but we don't use this in the spring. We wait till late summer when the river is nice and low, when warm temperatures have dropped that down. So very specific targeting has worked very well and dropped the lamprey population down. So the thing is, this costs $20 million a year to do statewide. $20 million spent on sea lamprey control alone. And when I talk to high school students, it's a lot of, so you're going to be a voter soon. If I told you that I was going to use, $20 million of your tax money to kill a fish that you've never seen, that kills fish that you don't care about, what would you say as a voter, right? You probably wouldn't care much. But if I told you it protects a $7 billion fishing economy in Michigan, that makes a little bit more of an impact. But what if I connect that to your real life, right? So when you go fishing, you buy a license and you buy bait and you buy a pole and some hooks. You might have to buy a boat and fuel for that boat. And then you drive somewhere to do it. Maybe you have to stay overnight in a hotel. You stop at a little restaurant to eat lunch. So that $7 billion economy makes a big difference when you connect all the dots, and some kids are like, well, my aunt owns a hotel, or, my uncle owns a bait shop. Well, it's more important to them when you connect it to their lives. So we're spending this $20 million a year to treat lamprey, and we pretty much have to do that forever and ever and ever. We can't stop until we come up with a better solution. So we're treating with TFM. We're using those weirs and traps. Our visitor centers, and normally I have live specimens of lamprey that we travel with in coolers with a bubbler, and we put them in a display tank and we get them out and we show how their mouths work, and we do programs with them because they pull those from those traps. So the USGS biological station in Ann Arbor, and then the Hammond Bay biological station up in Hammond Bay, and like way up there by Alpena. Both hold lamprey in tanks for research purposes and conduct a lot of this research, testing out new chemicals or new dosages and other solutions that could potentially come down the line. And then we get some of those lamprey to use for education programs. So normally you could walk into visitor center and see them in a tank, and it's pretty cool. So definitely take advantage of that at some point. So lamprey were a big problem, and they decimated the ecosystems, and they caused a lot of issues, but they weren't the only problem. So there was another one kind of coming down the pipe, because again, now we've connected everything out to the ocean, and we have ocean-going vessels that are coming in. They can possibly bring other things with them. And one of the things that snuck in was the alewife. So alewife are small fish. They're a bait fish is what it's called. So bait fish are small fish that other big fish eat. So this is, a 7-inch fish, kind of like a herring, that is native to the ocean again, but can hang out in the Great Lakes and thrive. And they did. So one of those things that makes something a good invader is that ability to reproduce fast and in large quantities, be adaptable, and outcompete other species that are like you. So these guys eat plankton, just like a lot of our other bait fish, and they grow fast, they reproduce fast. And when the lake trout population crashed, there was no longer a heavy predator for these species. So the lake trout used to eat the alewives and kind of keep them in check. But when the lake trout bottomed out, we had a lot of alewives out in the lake reproducing and eating plankton, but nobody to eat them. So huge die-offs were happening, and massive amounts of these were washing up on the beaches, especially in Lake Michigan, in feet deep, and piles and piles and piles of them. So if you're one of those landowners that has a $3 million beach house on Lake Michigan, this is not something you want on your beach. They're using bulldozers to clean these up. It was quite a mess. So there was a big public outcry at this point. The public didn't cry out as much when the lake trout disappeared, but when this started happening, it was very in their face and very noticeable, and there was a big public outcry to kind of come up with a solution. And at the time, there was a fisheries division chief called Howard Tanner, and he had previously worked out in the western states in a fisheries division out there, and had been brought back to Michigan to run our fisheries division. And the director at the time actually asked him to do something incredible, right? Do something amazing, extraordinary. So this was kind of his plan, is I'm going to fix this problem. And having been out west, you can kind of guess where this went, right? So Dr. Tanner obtained some Pacific coho eggs and brought those to Michigan. So nowadays, to do anything, we would have to have years of committee meetings and paperwork and all sorts of stuff and research and environmental impact statements, and back then it was simple as someone bringing some eggs from Washington in a thermos, and off the program goes. So the species that were available on the Pacific coast were the Chinook, which is the one we raise now for salmon in the classroom, chum salmon, sockeye salmon, pink salmon, and coho. So the ones that Dr. Tanner brought were actually those coho. And because of their life cycle, so the young live in the river until they smolt, which is turning silver, right? They swim out the river systems out to the Pacific Ocean, where they eat massive amounts of food. And then they come back a few years later, swim all the way up those river systems to spawn and then die. So he pulled these coho from Washington and brought them to Michigan. So it helps that their life cycle can cater to the Great Lakes. And that was his theory, is if they can adapt to freshwater to spawn and they live there when they're young, why wouldn't they be able to stay in freshwater? So a fish that swims back and forth between that saltwater and freshwater is anadromous, right? So anadromous fish can adapt their body in the way their osmosis works to, include or, exclude salt in the water, and they can swim up those freshwater streams. Well, when you bring them to a freshwater system and don't let them out, or don't let them back to saltwater, like the alewives had evolved to and the lamprey had evolved to, they have a different name. Anyone can say that one? So there's also potadromous is another way to say that. So scientists kind of go back and forth whether the MO should even be in there. But potadromous fish go into a large body of fresh water and then transition to those rivers to spawn. And then the young spend time in the river and then go back out to that large body of fresh water. So that's what potadromous is. So those coho eggs came, this is the eyed egg face. You see the little black dots on the eggs. Those are actually the eye. That's why it's called that. So we have these coho that have been brought to Michigan and they were put in the Great Lakes in 3 spots. So we have 1 in the Upper Peninsula on Lake Superior and then 2 on Lake Michigan side. So they drop these tiny little fish in and then hope for the best, right? So they spend a few years out in the Great Lakes. Well, they started coming back and it was a big deal. So for the first time kind of ever, there is a large fish in the Great Lakes that is fun to catch that comes near shore so you can wade out to fish for it. And you can also fish for them in rivers. So they're swimming up those rivers to spawn. They're coming near shore to, congregate to get ready to go in those rivers. So when these first fish came back, it got out to the fishing community. And most of these people didn't own boats. They definitely didn't own big boats. And they couldn't go way out in the Great Lakes, but they can go. Are my slides not showing up again? Jeez, oh Pete. Let's switch to me for a second, and then we'll switch back to the slides. Try this again. Okay. Hopefully it appears this time. It thought it was before. Are you seeing them now? Okay, great. So the coho, so here's those eyed eggs with the little black dots. And then they were released on Lake Superior and then again in 2 spots on Lake Michigan. They started coming back. So now you have all these guys and waders, lining the shoreline of Lake Michigan. And you have anybody who happened to have a boat for an inland lake launching their boats on Lake Michigan to catch these fish. From the stories I've heard, and there's some great footage. The Michigan History Center has a Vimeo page where they have a lot of this historic footage that they've posted. I mean, it was cars parked along the side of the road. If you've ever been to like Ludington State Park and you drive along that long road to get back there, bumper to bumper cars parked on both sides of the road, and every hotel all the way into the center part of Michigan was booked solid. It was a huge thing. And Tanner was quite excited about that, right? He had done something that not only maybe potentially could fix that alewife problem, but also has provided a new sport fishery. So that was in the early 60s. He thought that was so successful, the fisheries division, after he had moved on, decided to introduce Chinook as well, so another species. And the reasoning was they're a little bit more target specific on alewife. So coho are a little bit smaller, and they, let me reach my, whoop, dropping my fish. Coho are a little bit smaller than the Chinook. So let me pick up my life-size Chinook here. So again, big fish, right? They're also called king salmon in Alaska. But so here's our Chinook, right? Our, coho would be more slender, would only be, 2/3 the length. They are not quite as big, but they target multiple species when they eat. So coho will go to the surface and maybe eat eggs that are floating, fish eggs that are floating. They'll go in the middle of the water column and eat those bait fish. They'll drop down to the bottom and eat mullets or bottom going fish. They will kind of go all over the place to eat food. So they weren't targeting the alewives as specifically, where Chinook do that very specifically. So Chinook travel in the middle of the water, whoops, upside down fish, travel in the middle of the water column, and they pretty much swim straight ahead and eat the things in front of their face. Well, what little bait fish is in the middle of the water column right in front of their face? Alewives. So these guys would target alewives much more specifically. It doesn't make them as diverse, right, as the coho. So if there were low bait fish numbers, you were going to have low Chinook numbers, but you have this fish that's very specifically going to target alewives. It's also larger, It's going to hopefully come back to those same kind of rivers and spawn, and it is going to provide another fishing opportunity. And of course, that's exactly what it did. So Chinook come in, and now you have, even a bigger fishery. You can fish in the rivers for them as they're coming back, especially like these guys, at the base of a dam where you can, get them where they're kind of bottlenecked. So, and hopefully you're seeing slides again. So fishing became a huge part of Michigan and the Great Lakes culture, and specifically fishing for these salmon. So you're fishing out in the Great Lakes on vessels, going on charter boats. So a lot of those commercial fishermen that used to pull, gill nets and catch lake trout or whitefish or Cisco transitioned to being charter fishing. And a huge boom of charter fishermen, popped up over the state. You can also fish for them in the river, so it made it more accessible to a wider range of people. You don't have to have a big luxury yacht to go out and fish for these. You can fish in the streams. So that's where we come into play, right? So the DNR has to now manage this system. And not that we haven't for our whole 100-year run, but this was a whole different ball of wax. We now had to learn from West Coast fisheries departments how to rear and raise these little salmon, how to, trap or catch the adults to be able to spawn them, and supplement the wild population of these fish. And at the time, we didn't even know if there was going to be a wild population of fish. We didn't know if they were going to spawn effectively in the wild. So they started a spawning and stocking program using our hatcheries and using weirs around the state. We could start to purposely spawn and raise these fish and stock them in streams on purpose, right? So this was an important piece of the cycle. And it's not just the raising and the rearing of the fish, but it's also the research that goes back into it. So we have vessels on all of the Great Lakes, one on each lake. This is the former vessel of Lake Huron. It was retired a handful of years ago. And the new vessel is actually called the Tanner. So you can guess who that was named after. The Chinook is actually now on display at the Besser Museum in Alpena. So if you ever get up that way, you can actually go see the vessel. They're still working on the exhibit, but soon you'll be able to, kind of take a peek on and see what they did and have video clips of the research. So it's pretty cool. But we do research in the Great Lakes to understand the bait fish population, the predator population, how lake trout are doing, since they're our native big predator. And that's an important piece. And then these weirs, they actually come in up the river. They hit the weir here. They swim up a fish ladder into holding ponds, and then we pull them inside to spawn them. So very important pieces to keep all of these fish, happy and healthy, and keep introducing them to the system, and hopefully keep reducing the number of alewives is a huge goal, but also provide that sport fishing opportunity that's so important. The fish were doing well, then they weren't. So you may remember hearing about alewife crashing in the Great Lakes, and all of a sudden, salmon are crashing. The salmon population is plummeting, especially in Lake Huron as well. And this was kind of a big concern at the time, obviously, because this had become a huge part of that $7 billion fishery. So you can see, they were pretty high up there. There were some pretty good years in the early 2000s, and then they plummeted because alewives plummeted. And if you could think about it, so in the question and answer, anybody have a guess why alewives plummeted? What did I say they eat? So alewives eat plankton. What may have come in and hit a large population at this point that also eats plankton? Any guesses? So it's those invasive mussels. So zebra mussels, kawaga mussels, those came in and kind of decimated the plankton population, which decimated the alewives, which then impacted the salmon numbers, right? If they don't have fish to eat, they don't have the energy to reproduce, and then your population drops. So the population starts crashing in the Great Lakes. Thankfully, it has recovered since then. We found a new normal and a new stable kind of population. And a lot of that has to do with math, right? So when your students are like, why am I ever going to use math? this is a great reason why, right? We have biologists that spend a lot of their time doing math and trying to calculate that perfect balance, right? So I call it chasing the wave, right? You have to chase the plankton population, which affects the zebra mussels and affects the alewives, right? And the alewife population affects the salmon, but it's not just one species of salmon. We have Chinook, we have coho. There's accidentally some pink salmon in the Great Lakes. We now have Atlantic salmon that we've introduced to the Great Lakes. But you have the lake trout are recovering, so they also eat alewives. So you have all these fish that play together, and we stock a lot of those. Plus, you have steelhead trout. So we have all these pieces of the puzzle that you have to play the math game, and you know, stock the correct number of the correct species of fish in the correct places so that we don't crash that bait fish and alewife population and keep the fishery stable. So it's a huge thing. And you'll always see groups that are saying, well, we need more Chinook, or we need less Chinook, or stock more steelhead, or stock more brown trout, whatever it may be. And they all have their own reasons, right? And their own locations. And the biologists have to weigh out all of those things and try to balance that for a system that we can't control everything, right? We can control how many fish we put into the ecosystem, but we can't do anything about the alewives. So some people are always like, well, why don't you raise and stock alewives? Well, a salmon eats a lot of alewives, like 36 pounds of alewives in its life. And in order to raise alewives, we would have to convert all 6 of our state fish hatcheries to only raising alewives and somehow raise enough plankton to feed them. So there's the first problem. And if we did that and we devoted year-round production at all 6 hatcheries to only alewives, we could feed the salmon in the Great Lakes for 1 day. So not a viable answer, right? So it's much better that we keep an eye on what the baitfish population is and what the plankton population is, and do our magical math on the back end to balance that system out. And I saw Reef ask a question about the formulas, and I can ask our fisheries guys. They might share some of like the database data, because that's how your brain works, and that would be a great example for you. But we do that math to ensure we have a healthy population and we can keep a stable, healthy population for the long term. Because this is an introduced species. We brought it here. It's never going away. So other people are on the opposite end. Why do you use a non-native species for the Salmon in the Classroom program? Why do we even stock a non-native species? And we have that with a lot of things. Brown trout aren't native. We didn't have these other species of salmon. They're not native. But it's for that sport fishing opportunity, and sometimes to fill an ecological niche. So to eat those alewives to help control a system. And you have to balance that out as well. How valuable is the native ecosystem versus this introduced ecosystem that we manage? And that's a big part of what we do at the DNR. So, a lot of people think our funding comes from tax dollars. Only a tiny portion does. And we have this tiny portion of funding coming from, tax revenue, a huge portion of our funding coming from license dollars. So when people buy a fishing license, you bought one license, but what that does is it pairs with federal money. So we get like double the money back. We also get, there's excise tax on, fishing equipment and fishing fuel and boats and things like that. So there's federal programs, the Dingell-Johnson Act, if you want to look it up, if anybody, especially since Dingell's from Michigan. But that brings us federal funding that matches our state funding from license dollars, and that's what funds what the DNR does. That's really what our funding is from. So it's pay to play, right? The fishermen, the hunters that are, purchasing license to use and utilize the resource, they're the ones paying to protect that resource and to help manage it. So